Now, let's look at ratio and proportion. Ironically, proportionally, maybe not ironically, but just it's kind of weird because it is proportionally probably the biggest topic in GCSE. It comes up everywhere, like it comes up in ingredients questions, algebra questions, shape questions, vectors questions. So we need to be confident with ratio and proportion. And I'm going to do a quick whistle-stop run through some of the kind of questions. So in terms of simplifying, I'm going to give you like 10 seconds, maybe 20 seconds. Try and simplify these. And then we're going to talk about some slightly harder ones. Let's give it a go. And then we'll look at other ideas around this as well. So simplifying them is different from writing in the form 1 to n, which they could also equivalently ask. So simplifying is writing in its simplest form. So let's have a little look. For that first one, hopefully we go to 5 to 4. And then if it doesn't simplify anymore, we leave it. And we just kind of look to do it in its lowest terms where they're all still integers. If you got this, fantastic. And then there's some extra ones there for you. So let me just write these in quickly and check we're happy. And do feel free to pick up on any intentional mistakes I might make. We're here, the highest common factor, 2. And I'd stop there. A little bit like simplifying fractions in that we're just sort of cancelling down. So 50 goes into 100 twice, so it goes into that 20 times. And 3 goes into all of this. Now, these ones do catch people off guard. Because sometimes you have to simplify up. We don't want decimals and we don't want fractions. So this one you would actually have to double them all, or basically undo the denominators. So you'd end up with 1 to 14, 4. I've actually had to times through by 2. So do look out for that as well. And equivalently here, the smallest fraction is 4. So it's a quarter. So a times through by 4, I get 1 to 2 to 20. And if we look at it, that is still the biggest, that's middle, and that's the smallest. So we sense check it. But just look out for that, because that sort of throws us off sometimes. Now, combining ratio, these sorts of questions, I want to just check we're kind of happy with. So if I said, for example, dogs to cats, I did a sample about pets, was 5 to 7, and cats to fish was 3 to 2. And I want to combine them. The idea is to put them all together, and the link is the cats. So if I write those underneath, I know I've done an example to the left, I'd write 5 to 7, and then underneath I'd write 3 to 2. And this is the thing that needs to be the same, so they're comparable. They both go into 21, that's the lowest common multiple. So how did I get 5 to 7 to something to 21? I had to times that by 3. If I times that by 3, I get 15. Now 15 to 21 is still 5 to 7, but I've just dressed it up. 3 to 2, I've times that by 7, so I need to times that by 7. So 21 to 14 is 3 to 2. But now I've got them all in one single ratio. If I could simplify it, I would. But now this allows me to have anything. I can compare all 3 together. I could also compare dogs to fish, 15 to 14. I can kind of obtain any ratio I want from that. Now, scale factor is another part of ratio and proportion that comes up in a lot of ways. A really, really sort of big thing that keeps getting tested is area and volume scale factor. So if you enlarge something, the scale factor is to do with the length. So if I double something's length, the area doesn't get 2 times bigger. The area actually gets 4 times bigger. So if you imagine a 1 by 1 square and I enlarge it by a factor of 2, it's now 2 by 2. But because that's in 2 dimensions, the factor is literally called squared. That's why we call it squared. because it's like in 2 dimensions. And similarly, if I did a 2 by 2 by 2 and a little 1 by 1 by 1 cube, and I times it by 2 in all 3 dimensions, I would now need 8 little cubes to make it. So that's 2 cubed, and that is actually why we call it cubed. So just notice that about the scale factor, that as you move into another dimension, you go up the powers. So here's a really good question I'd like you to try. Classic kind of GCSE one that's very popular at the moment. And I'm going to let you have a little think about this. And then we're going to walk this through together. So I'm going to give you a minute or so to try it. I'm just going to check the Q&A, and if there's any questions, please do let me know. But yeah, have a little try of this particular question, and then we'll walk it through together. We're going to hit some of the really harder kind of trig content as well, and I'm going to give you a few little tricks and tips for all of this stuff. But do try this question now. Okay, so also just to let you know, so we're going to keep pushing through the slides, and then at the end we can kind of review everything in the Q&A, and I can kind of give you a bit more access to see what we've gone through. But right now, let's just give this question a go, and then I'll talk about that again in a minute. Right, and I've got the Q&A open, as I said. Right, let's see how we go. I'm going to be quiet for a further 40 seconds or so, and then we'll walk this through. So the slides have just been put in the chat as well. You might have been able to see that. But what we're going to do, we're going to walk through this together, because there's a few things, especially this afternoon session, is a lot more kind of explaining and how techniques for approaching these harder questions. So I would still like you with me on this. Oh, okay. If you can't see them yet, we'll sort that later on. But as I said, if we can all pay attention to this as we go, then later on I'll make that viewable in the chat if that hasn't happened already. But it's just so you have a bit of a heads up, those that were panicking about that. But I do want us just looking at these techniques as we go for this afternoon, because we're hitting the harder stuff. So let's have a little look at this one now. Volume of the sphere A is 125, volume of sphere B is 27. And then it says about the ratio of the radius. Now, what I would set up is I would start by putting that bit of information as a ratio. And what a lot of people don't realize you can do is you can cube root, or square, or cube a ratio when you're moving between dimensions. So if the volume is 125 to 27, rather than finding a scale factor, you can literally cube root that to find the length scale factor, which would be 5 to 3. And in a similar way, the radius, which is a length for the two spheres B to C, is 1 to 2. So since the final bit of the question wants us to work out the area scale factor, it's the technique we just did of combining these two length scale factors, A to B to C. And the lowest common multiple is 3. So we do 5 to 3, and we just need to times this one by 3, 5 to 3 to 6. So this is what the lengths or the radiuses are doing. They're in that sort of ratio. And because it asks us the ratio of the surface area, that's an area, we square all those values. And it asks us for the ratio of A to C. So it'd be 25 to 36. If you have any questions on that, please let me know, because I think this is a brilliant question and it comes up quite a lot. And the point is, you can just square root or cube or whatever you need to do to the ratio, right, if you don't know the scale factor. So this to this represents the length, So if I square it, it represents the area. If I cube it, it represents the volume. Okay, so I've got the Q&A open if there's anything you want to come back to on that. Otherwise, we'll keep pushing forwards. So there's your mark scheme on that one. Now, direct proportion. Again, some people are absolutely fine with this, others don't like it as much. Let's have a little look. So something that's directly proportional is actually a graph that goes through the origin, and it's a straight line graph. So it's like something of the form y equals kx or mx. The gradient is the constant of proportionality. Something that's inversely proportional means it's like something over x. So it's like one of those reciprocal graphs. Now, if we have these statements, this little proportional squiggle thing throws people off. That statement says y is proportional to x squared. And that's how you sort of shorthand denote it mathematically. Now, that's not overly useful written like that. We'd rather turn it into an actual equation. So when you want to swap it out, that's the statement of proportionality. When you want to swap it out for an actual equation, you can replace the proportion symbol with an equals and a k. So y is proportional to x squared means y is equal to some scale factor times x squared. Y equals something x squared. So we know like the family of curves it comes from. It's some sort of quadratic. And the same for each of those. Right, so let's have a little look at this example. Okay, so y is directly proportional to root x. When y is 75, x is 100. Find a formula linking x and y. Very common question. This will absolutely come up. Yeah, oh, sorry, absolutely. They were just examples, by the way, on the previous slide. So is that what you meant? Is that what you wanted to see? Hopefully that answers your question. So what we've got is with these questions we're about to do, they never ask you to find k. You kind of have to know to do that. One sec, sorry guys, I think I'm going to sneak. Yeah, apologies for that. Okay, so let's move on. So this one, you have to find k, but they've not even mentioned k. So let's give this a go. So let's have a little look. So the first thing I would write is we could write, y equals to k root x. That will be a mark. And this is where most people struggle to get started with this, because the question doesn't mention k. It says directly proportional. So some people will write this, which is great. But how do we get anywhere with it? We turn it into an equation and we introduce a scale factor. Then again, like before, we've got a pair of values to sub in, and they will always do that. You'll have to have that. So that will also signify that it's this skill. So if we sub that in, we can find k by rearranging that, and obviously sub those values in. So you might sub this first in as 75, and then this is 100, rooted 100 and got 10, and then divided it. The 75 divided by 10 is 7.5. Now we've found k. So k is a constant, it's fixed. We found the bang-on equation that meets all that information. So then if they say, well, what about when x is 4? Or when x is this? You can then sub in other values and work out what's going on. So please let me know if there's anything you're unsure of with this, because this is a major trick for a lot of students. I'll just give you a minute to take that in. Now let's have a little look. So here's another one. And again, this is actually the same question, but in a bit of a different kind of, it looks slightly different, but it's actually exact same. So this time they've done it almost as a little table of values, and they've given you a pair that work. So y is proportional to root x. So y equals kx, k root x. And here's my pair of values. When x is 36, y is 2. So let's find k. Once we've found k, we've found the actual formula, then they've given us another pair to solve and find out what a is. So there's what I do to start with. I plug my pair of values in. When x is 36, y is 2, k comes out as a third. So the actual formula is y equals a third root x. That's actually the graph. That's actually the function we're dealing with. And now we want to see, well, when y is 5, x is this unknown thing we're calling a, and we can rearrange and find out what a is. So you can times that by 3, and then we can think, okay, I can then, times up by 3. Have I done that right? 15. No, that looks wrong. 7. And then square both sides. And a is 15 squared, which is 225. Cool. So, in a very similar fashion, when it's inversely proportional, it means it's proportional to like 1 over, which means when you times by k, you actually affect the numerator, like we said earlier with fractions. So the k sort of affects the top, because k, you can think of that as like k times 1 over x squared. But it's really affecting that bit, because it's like k over 1. So the k goes in the top part of the fraction for each of these. Now, let's have a little look at some examples. Y is inversely proportional to root x. So this time, y is equal to k over root x. So to find the constant, we sub x and y in, and we rearrange to find k, and we get k is 12. So this time, the actual equation is 12 over root x. And that's it, we've done it. Again, stop me if you're unsure. We are going to push on to trig and some hard problem solving in a minute, but this is a big topic that costs people marks. And again, it's because people don't know that they've got to find k to start with. So here's another one. I'm going to let you try this. And I don't want to talk at you. I want you to have a minute to think. So give this a quick go. Brilliant. And then we'll push on again to, as I said, some of the hard questions. So x and y. Now this time it says y is inversely proportional to the square of x. Oops, not the square root of x, to the square. So y is equal to k over x squared. We've got a pair of values. So we can rearrange and find k and work out k equals 9 times 10 squared, so 900. And this is actually the equation. And all these values will have to fit into that as well. So for this one, if we want to work out when x is 6, we sub that in and we find that y is 25. That's almost like part B of the question. Now, if I want to work out when y is 4, we sub that in and we set 4 in as y. Or you could make y the subject, but you could say 4 is equal to 900 over x squared. Times up by x squared, divide by 4. And then square root, you get x is 15. Okay, so they're almost like your 2 spin-off questions. But they could like not guide you through this at all. They could just give you the table. So you have to establish the rule at first and then sub the other relevant bits in. Right, here we go. So have a little think about these. 20 seconds and we want to match them up. Give them a go. Right, so y is directly proportional to x, remember, is a sort of linear situation. Y is inversely is like a reciprocal. Y is inversely is proportional to the square, it's like a quadratic, and inversely proportional to the square is kind of by elimination the other one. So this first one is the straight line. This is the reciprocal. This is the quadratic one. This is the kind of quadratic reciprocal that you wouldn't have known, but maybe could have worked out by a process of elimination. Right, let's keep going. And again, look, so whilst this is matching functions, they can relate it to proportion, they sometimes do, just to disguise it as an extra topic. And again, inversely proportional to x is like 1 over x. Is proportional to a trig function. Well, that's the only wavy one. An exponential has to be that one. And the root is that one, again by elimination. So